So we are starting the session. Okay. Uh, Hello, everyone. I hope you all are doing good and doing well. So today we'll be learning about homologation and testing. So my motto today will be to familiarize you all with the term which is homologation. And you might have heard about this term before, but if you have not, so even if there is no issues, because we are going to learn about it in the session today, and I will make sure that you will receive a lot of information about what is homologation and everything. So let's not waste the time anymore, and we start the session. So let me tell you what all the topics we'll be covering today. So as you can see on your screen, there are several topics that I have mentioned. First is obviously introduction to homologation. Then we have importance of homologation, vehicle categories for homologation, regulatory bodies, steps involved in the process, testing parameters, and career in homologation. So these all are the topics that we are going to cover in today's session, and I will make sure that in the session you will get to know everything about all these topics. We will definitely not go in too much depth, but I will try to make you give you a gist of all the topics that we have just discussed here. So are we ready? Let's start the session today. So coming on to the first topic of our session, which is introduction to homologation. So what is homologation? So first of all, as soon as you have seen this presentation, the slide, it was there homologation and testing. So for the people who have not heard about it and who do not have any idea about it, what is homologation? So let me tell you what is homologation. Homologation is nothing but a process of certifying the vehicle which complies the necessary technical and legal requirements which are there to make the vehicle roadworthy and safe for public use, as well as safe for the people who are driving it and are sitting in the inside the car or vehicle as passengers. So if you go by the definition, so this is what homologation means. That means, let me tell you in a layman language. So it is a set of safety tests, emission norms, and other than that, there are a few more compliances. So it's a whole process of all these norms and tests and everything, and this whole process of these certifications is called the homologation process, or homologation we call it. And also this is one of the important aspect in the lifespan of a vehicle, because if homologation is not there, I don't think you can see any of the vehicle present on the road in the future if homologation is not there. So moving on, importance of homologation. So we were actually talking about importance. I have just mentioned only. So when I say importance of homologation, I feel homologation is basically one of the most important part in the entire journey of a vehicle. And by journey, I mean from design part, when the vehicle is in the ideation form and when we design it. So from there to the final end product, which reaches to the consumer, like for people like us, like we go and buy cars and two-wheelers, right? So, so the journey from design to the end product, the importance of homologation is a lot. So, and in this importance, there are like significant aspects also. So we will be going through all these aspects one by one. So the first aspect here is guarantees roadworthiness. So by guarantees roadworthiness, what do we mean here? So basically, what is happening right now? uh, Homologation is the process where we are getting all the certificates of safety and everything, right? So when we're getting to know that if this product for say Tata Nano or maybe Tata Nexon or any other vehicle you talk about, they have got some sort of safety rating, right? So when we hear all those safety ratings, we have this feeling of we find contentment with the safety rating, that okay, this car is safe, this vehicle is safe, and we can definitely uh, use this vehicle, and even if we met with any accident or something, we will be going to be fine only, right? So that is what that is what the term guarantees roadworthiness means. So if we go by the definition here, we see homologation ensures vehicles meet strict safety standards for brakes, steering in electric vehicles, motors, battery, and overall structure of the vehicle, which will minimize the road accidents and head-on-head collision or maybe side collision and all. So this was the first aspect. Now we have the second aspect here, which is protects our environment. So we all know that we are talking about automobile here, auto vehicles and everything. So the we know that environment is like all the production of all these vehicles is actually harming the environment, but not on that level. So we always try to regulate the emissions, and these regulations are also coming under homologation process only. So homologation, what it does, it regulates the emissions, and noise pollutions are also verified there, which are there to promote the cleaner air and a quieter drive experience. I hope I'm clear till now. So moving on to the third part, facilitates global trade. So with this aspect, this is actually for the this is not actually for us, for the end consumers, but it is for this particular aspect is for the manufacturers. So we can see it is written that standardized testing allows manufacturer to sell vehicles in multiple countries without extensive recertifications. So what do you mean by that? So let me take you a little, let me tell you a story. It is actually not a story, it's actually true. So some time ago, what it used to be happening. So for example, I am a manufacturer in India and making a vehicle in here in India, and I know that the what are the Indian road conditions are, what are the driving dynamics of us Indians are, right? So according to those parameters, we have some regulatory bodies who have designed and developed some sort of tests and certifications. And in India, I made the vehicle according to those tests only, and I passed and cleared all those tests. So I am eligible to sell my vehicle in India. But if I have to take this vehicle to another country, for say Japan, for say South Africa, or any other country, so we can definitely observe that the driving type, like the driving dynamics of those countries and road conditions and rules and regulations are different than India, right? So they have earlier every manufacturer used to get certifications from every other country where they are actually selling their products. But nowadays, it is not like that. So a lot of global regulatory bodies have come together and they have standardized the tests for homologation, where which are actually acceptable globally. So even if, for say, if I am making a manufacturing a vehicle in India, but I'm getting it manufactured according to these standards, I am I don't need any sort of recertifications to sell the vehicle in any other country, right? So this is the third aspect. Now moving on to the fourth aspect is empowers consumers, which means homologation provides peace of mind, knowing vehicle adheres to established safety and environmental regulations. That means that I've already mentioned here only, like I've mentioned a couple of minutes ago, that when we know that the vehicle is going through a strict safety procedure, safety standard procedures, so we as end consumers have this sense of security that yes, we will be fine in this vehicle, we will be safe in this. So that is what empowers consumers meaning here, right? I hope this is clear to all of you, and why I was emphasizing on the importance of homologation. So homologation is very much important. So these are the key aspects why there are so much importance of this homologation process. Moving on, vehicle categories for homologation. So this is our new segment of the session, which is vehicle categories for homologation. So we all know that we, like in the current scenario also, every day we go out and we see different type of vehicles on the road. We have two-wheelers, three-wheelers, four-wheelers. Then we have trucks. Then we have construction equipment vehicles, and like very different kind of vehicles, right? And as I have already mentioned, that homologation is necessary and important for every sort of vehicle out there in the market. So all these type of vehicles that I've mentioned just now, they also go through with these tests and safety procedures, but all of them have different parameters. So for example, if I'm talking about a four wheeler, passenger four wheeler like a hatchback or a sedan, so uh, that particular vehicle will have a different sort of tests and security, oh sorry, not security, safety standards, and in comparison to a truck, or maybe we can say an excavator which is used in the uh, construction equipment vehicle. So we know that the safety standards of both of these vehicles will be different. The parameters will be different, right? And then how do we categorize them? How do we know which one should be which one test should be with the other sort of vehicle, right? So to be able to categorize, to be able to get all the homologation process done for different sort of vehicles, we have like different vehicle categories here. We have made so many vehicle categories here, and those vehicle categories are as follows. As you can see on your screen, I hope it is visible, right? Can you all confirm this is visible? I'm assuming it is visible. So
Could you zoom in a bit?
actually, it is already in the presentation mode. So
Then okay, sir. Okay, it's visible.
yeah, yeah. Okay, I'm will be explaining all those categories in briefly also. So let me just tell you first what all categories we have. We have in total we have six categories, and those are category A, category C, category L, category M, N, and T. So as you can see, category L have five other dimensions, or we can say subsections. Then we have category M, which has three subsections. Then we have category N, which also have three subsections. Right. So let's talk about all these categories uh, in a brief way. So coming to the category A first. So as you can see on your screen, in the first two pictures, we have a trailer and a tractor, right? So category A deals with the sort of vehicles which are actually used in the agricultural sector, right? So we have trillers here, we have tractors here, we have backhoe extenders here, and then different equipments as well, automotive equipments as well. All these automotive equipments uh, which are actually getting used in the agricultural sector are coming into category A. And these have like a different sort of testing regulations and safety regulations and norms and compliances. Okay, so by these categories, we are actually determining what sort of compliances they are going through, right? So now the second is category C, which are construction equipment vehicles, CEV, where you can see in the picture we have a forklift, we have a tipper, or we can say dumper. Then we have in this category also we have cranes, we have excavators, we have JCBs and all. All those construction equipment vehicles will fall in this category. Coming on to category L, as we have seen in the flow chart, that category L was divided into five other subsections. And here we have the five subsections naming as L1, L2, L3, L5M, and L5N. So let me tell you, category L is considered for two-wheelers and three-wheelers. Okay. So, and in that too, in category L1, we have vehicles whose maximum speed is up to 45 kilometer per hour, not more than that, only 45 kilometer per hour. And the engine capacity is about 50 cc. If it goes more than 50 cc, it will not fall in category L1. Okay. Now, moving on, we have L2, motorcycle other than category L1. I hope this is clear, right? Then we have L3, speed exceeding 50 kilometer per hour. Okay, so in L1, what is happening? The maximum speed was 45 kilometer per hour, but in L3, the speed is actually exceeding from 50 kilometer per hour. Okay, and the engine capacity exceeding here is more than 50 cc. Or if it is an electric vehicle, then the motor power is greater than 4 kilowatt. Okay. Then we have the fourth category, which is L5M. So this is a passenger carrier. We all know auto rickshaws, and the gross vehicle weight is equal to 1500 kilograms, and not more than that. Okay, so it should be, the gross vehicle weight should always be under 1500 kilograms. Okay, and then later on we have L5N, which means motorcycle other than category L1, right? So here on the screen you can see category L, three-wheelers. You can see we have four different subsections in the three-wheelers part as well. So we have vehicle category L5M auto on the first picture. Then we have L5N cargo. Then we have e-rickshaw category and e-cart category. And we have written the information as well, where in L5M auto, the engine power is greater than 25 cc. Or if it is a motor powered, so it is greater than 250 watts. Okay, and the maximum speed is also greater than 25 to 30 kilometer per hour. And we have the seating capacity, which is driver plus three people, maximum four, which includes driver as well. And in the cargo section, everything is same, only the seating capacity changed, because in the cargo part there is no passenger, so only driver will sit. Now coming to the third picture, e-rickshaw category. where the motor power is almost equal to 2 kilowatt. Okay, not more than that. And the maximum speed is 25 to 30 kilometer per hour, where the seating capacity in e-rickshaws are driver plus four. So in total five. And in e-cart, the power figures are same, everything is same, except the seating capacity, where seating capacity is only of one, which is the driver. Then coming on to our next category, which is category M, four wheelers. So four wheelers are also categorized into five subsections, which are M1, M2, M2G, M3, and M3G. So let's go about it one by one. So in M1, we have motor vehicle used for carriage of passenger, not more than 8 seat in addition to the driver's seat. That means in a vehicle, 7 people can sit as passengers and the eighth person should be the driver. So in total, 8 people can sit in a four-wheeler. So that four-wheeler comes under M1 category. Then we have M2 category, where the maximum passengers are not not increasing 9 seats. Okay, and the maximum gross vehicle weight is not exceeding 5 tons. So the complete weight, the gross weight of the vehicle should be under 5 tons, and the seating capacity should be nine only. I mean, not crossing nine. So then it will fall into this M2 category. Then we have M2G. In M2G category, it is similar to M2 category only, but the vehicle have off-road capabilities, or we say cross-country capabilities. The vehicle can climb and vehicle can go off-roading a little bit. So if the vehicle have that capabilities, it will fall under M2G. Now we have M3 category, where the gross vehicle weight is actually exceeding 5 tons, and the seating capacity is same as of M2. Then we have M3G, which is also similar to M3. Just as M2G, that M2G has the off-road capabilities. Here, M3G also have the off-road capabilities. I hope this much is clear. Moving on to category N, four-wheelers with load carriers. So this is the load carrier category. So we have in category N, we have N1, N2, N3, and these categories are divided on the basis of the gross vehicle weight. Okay, so in N1, the gross vehicle weight is actually not exceeding 3.5 tons. That means the gross vehicle weight is under 3.5 tons. Then we have N2 category, where the weight is ranging from 3.5 ton to 12 tons, and it is not exceeding 12 tons. It should be under 12 tons only. Then it will fall into N2 category. And later on, we have N3, where the vehicle weight is actually exceeding 12 tons. Okay, so as you can see in the picture we have mentioned here, in the first picture you can see a Mahindra pickup, right? So that Mahindra pickup comes under N1 category because the gross vehicle weight is 3.5 ton. So if you have a little bit of knowledge about it, the loader of this pickup actually is able to take up to 1.2 to 1.4 kilo tons of weight. Okay, carrying capacity is 1.2 to 1.4 kilo tons. Then we have N2 category. We can see a full size truck which has the capacity to take up to 12 tons. And then in N3 you can see a tipper or a dumper which goes more than 12 tons. So, like when it exceeds 12 tons, usually these tippers weigh somewhere around 20 to 30 tons. Moving on, this is the last category we have, category T, trailer category. This also has five subsections, and this is also divided on the basis of gross vehicle weight. Okay, so in T1, the weight should not exceed 0.75 tons, that is 750 kgs. Okay, and then in T2, it should not exceed 3.5 tons. Okay, it is ranging from 750 kgs to 3.5 ton. And in T3, it is ranging from 3.5 ton to 10 ton. And in T4, it is ranging, oh, sorry, not ranging, but it is exceeding 10 tons. Okay. And then we have a quarter cycle also, which lies into the T5 category. Okay. So these were the whole categories that are there in the homologation process. Yes. So moving on to the next section, which is automotive testing institutes and testing labs. So in India, we have like very renowned and so many testing institutes where we can conduct all these tests. We can get certified, and this we can compliance with all the norms there. So we have like I have mentioned here some which are ICAT, we have ARAI, we have NATRIP, NATRAX, DRDO. So ARAI, which is Automotive Research Association of India, is in Pune. I am sure you all have heard about ARAI. Then we have Vehicle Research and Development Establishment, VRDE. This comes under DRDO only, and it is in Ahmednagar, Maharashtra. Then we have ICAT, International Center for Automotive Technology. This is in Manesar, Haryana. Then we have CIRT, Central Institute for Road Transportation. This is also in Pune. And lastly, we have NATRAX, which is National Automotive Test Track. This is in Madhya Pradesh. The next part is steps of homologation. So let me just tell you what all steps are there for the homologation process. So when we have just to give you an example that the what is homologation, when we I was giving you the uh, definition of homologation. So there I told you that it is basically uh, the process of getting all the certificates and test and compliance with all the norms, right? But it is not actually started from where the when the vehicle is in the life form, or we can say in the end product form, but it actually starts from the design stage. Okay, so the first step here is pre-homologation, which is design and development phase. So what happens here when we are talking about pre-homologation stage? So when any vehicle is being made from design to the prototype stage, the vehicle is actually being designed in a way where it is able to go through multiple tests, and it can withstand with all those tests alone, so that then only we can go ahead with the prototyping stage. What does that mean? Basically, you all know that when we are designing a vehicle, we are designing it in a way where if the vehicle is actually, for say, if the vehicle is colliding with something, like there's a wall in front of the vehicle and the vehicle is colliding with it. So in front of the vehicle, we have a crumple zone, right? So we do simulations of those, we do analysis of those, and we find out that the crumple zone is actually how much the shock it is actually distributing to the body and not giving it to the passenger or the driver, and making the vehicle safe, right? So this whole procedure starts from the design end only. As soon as we are designing, as soon as the designs are complete, It goes through the simulation process where we are doing a lot of tests, just like static tests, which are stress tests, and then there is bending test, then there are CFT tests, which are for aerodynamic of the vehicle. Then we have obviously this crumple zone test. So all these sort of tests are done in the design and development phase only. So this is considered to be the first step of homologation. Now moving on, the second is prototype testing. So as soon as the design part is done, our design is approved, we have received all the certifications and everything, we go to the next step, which is prototyping, right? Go to the industry, we go to the factory, we make a prototype of the design that we were actually going to. Okay, and as soon as this design comes to life as a form of prototype, we try to do all those testing that are required on the various parameters on this prototype. And those parameters are safety, emissions, and performance. There are multiple parameters which are also there, but those come in the later part, right? Like we have to get a lot of approvals and all. I'll explain to that, but in the later part. The third third step is conformity of production, that is COP. Now, what do we mean by conformity of production? What is COP? As you can see, it is written ensuring ongoing compliance during mass production. And what do you mean by that? So basically, uh, when we are talking about homologation, so for homologation, for getting all the tests done to getting or getting the certification and all these compliances, we mostly use 1 or 2 units of the vehicle, right? But that particular vehicle is actually being manufactured in mass production, right? That vehicle has been manufacturing a very huge factory where it is, every day they are making 100 or 200 units. Okay, so there we have to maintain that whatever type of material that has been used for the prototype vehicle will be used in the all production level cars, all mass production level cars. Okay, or whatever sort of strategies that have been taken while developing that prototype vehicle, or any sort of mechanical or electrical or any sort of procedure that has been taken while developing those test car will be taken with mass production level cars as well. So this is one of the important aspect of steps of homologation when the vehicle is producing on a mass level. Okay. The fourth part is certifications. Obviously, when everything is done, we have got all the tests, we have made the design, and everything is made. Then final product is ready, and to be able to take that product from factory to market, we need final approvals, we need certifications. So this is the last step where we get all those certificates and approvals. And when I'm talking about approvals, there are a lot of approvals that automotive industry has to get when they are launching a vehicle into the market. Let's learn about some of the approvals here. Yeah. So as you can see on the screen, I have mentioned somewhere about 17 approvals. Okay. So we can go one by one. One is passenger protection. In this one, seat belts are there. Okay. So we are actually getting the approval for seat belts. Then we have child restraints. Child restraints, in this part, we are getting the approval for the child seat, if you know about the child seat. So this is the approval for that. Then we have seat belts. Then we have steering system, brake system, warning triangle, mirrors. horn, general lighting, field of vision. In this field of vision, wipers and the front glass, quarter panel, back glass, all these comes. Then tires are there. Then fuel consumption and consumption is there. EMC, air pollutants, noise emissions, rear view system, and tank. So all these approvals are there that we have to take when we have to uh, get the manufactured vehicle into the market and sell it to the end consumer or customer, right? So, and these are not the only approvals. These are some of those which are top on my mind, but there are multiple approvals as well. Even like for say there are 20 to 30 more approvals that are still there that we had to take. Okay. So coming to the electric vehicles also. So in electric vehicles, we have to get some additional approvals as well. And I have written three most important approvals here. So first is the measurement of net power and maximum 30-minute power of electric motor. So which means because we all know that the propulsion system in the electric vehicle is mostly motor only, right? So we have to get the motor approval. So which is this is the first and foremost approval that we have to get. Now, second is electric vehicle battery charging and discharging test. That is the approval for the battery of the electric vehicle that we are going to use. Okay, and then we have to take approvals for power electronics. So in power electronics, we can consider uh, motor controllers, we can consider chargers, we can consider BMS, BTMS. All these components can be considered as power electronics, and we have to get approvals for all those components before fitting it into the vehicle. Okay, and also when we are talking about EVs only, so electric vehicles have to go through a six level of validation system, and that six level of validation system is basically you can see on the screen. There is element level validation, component level validation, subsystem level validation, then powertrain validation, vehicle validation, and on-road validation. So what are all these validations? So let's go through one by one. So when we are talking about element level validation, so what is happening here? So in electric vehicles, we are using a lot of different kind of elements. For say in battery itself, we are using lithium-ion battery, and the chemistry we are using currently like NMC and LFP, which stands for lithium iron phosphate and nickel cobalt manganese. So all these are elements only, and we have to validate the element level, which is if the element is right or if the element is wrong, if the element quality is right. So we have to validate all these aspects and parameters. Okay, so this is the first level. Then we go to the component level, where we are actually validating the quality of the components. And by components, what I mean, so by components, for example, if you're talking about a motor is also a component. So we have to validate the motor, we have to validate the battery, we have to validate the motor controller, we have to validate the electronic other controllers. Okay, so we have to validate all the components before putting it into the vehicle. Then we have subsystem level validation. So we have to make sure when all the subsystems are working properly and there is no issues. So that validation is there. Then we have powertrain validation. As I've already mentioned, that motor and battery and all that we have to validate. Then we have vehicle validation, which is on lab level, where once everything is assembled, so we validate it in the lab level, we check everything, and we give a clearance to the vehicle. And then the last part, vehicle goes on the road, and we do the on-road validation. And what is on-road validation? In on-road validation part, mostly comes the mechanical validations where we are actually testing the power of the vehicle. Like for say, we are testing the acceleration of the vehicle. We are testing the performance. We are testing the performance of brakes. We are testing the performance of cornering of the vehicle. The steering mechanism we are I'm talking about here. Like ESC is there, electronic speed controller is there. So if it is working fine or if it is not working fine, how is the steering feedback when it is going on the plain road or when it is in the off-road mode? So all those validations are done on road. So all these are the 6 levels of EV validation, electric vehicle validations that we have to get. So I hope this is uh, clear to everyone. So now moving on to the next part of our session, which is test types for homologation of vehicle. Okay, so we have to consider a lot of different tests to get the homologation process done, to get different sort of certifications done. So I have mentioned few here, which are brake surface test, hill track test, accelerated fatigue track, then handling track for 2 and 3 wheelers, then wet skid pad track, then external noise track. So all of the tests you are seeing here, right? These all tests are done under one facility, and which is this facility? Let me tell you. So this facility is NatTrax. We were just reading about it. So as you can see in the picture here, NatTrack is NatTrax is Asia's longest track. Okay, and it is in Madhya Pradesh, Indore. So the legal speed of this track is 325 kilometer per hour, which means the vehicle can go up to the speed of 320 kilometer per hour on this track while testing. So which makes it the international level testing track. Uh, okay, and the goal of this track is high performance vehicle testing. Okay, so we have to when we have to test the vehicle on high performance, right? So this is the whole goal of this track. So in this nat tracks, we have like different tracks for all sort of tests. So as you can see, yeah. So probably my screen is visible to all of you. So you can see we have different platforms here. We have high speed track where we can actually check what is the high speed of the vehicle. Okay. Then we have dynamic platform. On this dynamic platform, we are actually checking the steering of our vehicle, the steering angles, the turning, the cornering, the cornering, and the turning radius of the steering, and stability of the vehicle when we are actually going to the curbs and turning it on high speeds. So for all those tests, dynamic platform is used. Then we have multi-friction braking. So in the third picture on right, top right, third picture, if you all can see. So you can see there are 3 or 4 colored lines. All these colored lines are different sort of materials that has been there to change the coefficient drag coefficient of the sorry, not the drag coefficient, friction coefficient of the surface to find out the braking aspect of the vehicle. Okay, now then we have gradient track where we have different gradients, and by gradients I mean the elevation. Okay, so we have 5 degrees, then we have 10 degrees, and so on. So we have gradient track. Then we have fatigue track, where we are actually testing how much the suspensions are, how the suspensions are working, how the stability of the vehicle is there, how much the vehicle is stable, and even if long drives, what sort of fatigue is actually giving to the driver, and how much the systems and subsystems are getting into fatigue. So for all those tests, we have fatigue track. Then we have gravel and off-road track. So where we are actually testing the off-roading capabilities. Then we have, sorry, yeah. Then we have comfort track, checking the comfort of the vehicle. Where we are actually checking how much the engine noise is coming to the cabin, how much the road noise is coming to the cabin, and what are the vibrations and are there in the vehicle. So all of these are checked on this track, which is comfort track. Then we have handling track for two and wheelers. For two wheelers and three wheelers, we have this, zigzag sort of a track where we can see a lot of turns. So we can definitely find out the handling, or we can definitely test the handling of two and three wheelers here. Then we have wet skid pad and noise track. So two more tracks are there. So all these tracks are there in under one facility, which is in Madhya Pradesh. And this is like a global level facility. And we can perform almost every test there. So Natrax is one of the leading organization right now. I hope this much is clear to all of you. Moving on. So moving on to our next topic, which is automotive safety. So when we are talking about automotive safety, we have to take consideration of a few points, which are emergency case, road safety, road engineering, vehicle engineering, entrapment and enforcement, and we have to also consider about the environment as well. Okay, so these all things that, we have to take in consideration. So let me tell you something about active safety system. So before going into active safety system, we are talking about automotive safety. And in automotive vehicles, we have the two different kind of systems, which are active systems and passive systems. Okay, so in active systems, we can see, as you can see on the screen, we have active safety systems. In most of the cars right now, we have active safety systems, which are ABS, anti-lock braking. Then there is ESC, electronic stability control. Then we have autonomous emergency braking. Then we have lane departure warning. All those systems are there in today's, if you are talking about cars which are coming in today's market. And why are we calling them active safety systems? We are actually calling them active safety systems because they can prevent accidents from happening altogether, or actively help the driver to reduce the impact, right? So when we are actually using ABS, or maybe when you are using autonomous emergency braking, so what is happening in ABS, autonomous emergency braking? The vehicle is actually detecting if there is a, vehicle or a object in front of it, and it automatically applies the brake to the vehicle, and it comes to rest. So either the vehicle comes to the rest and avoid the collision, or the vehicle speed will be reduced, and the even if the vehicle collided with something, the impact will be very less. So that is why we are calling all these systems active safety systems. Then we have passive safety system. So what is passive safety system? For example, if the collision is happened, so if you have met with an accident, or there is a collision that has happened, so at that part there should be some sort of systems that are protecting you, and those systems are, first is obviously the seat belt that we all wear. Then we have airbags, and then we have deformation zones. Deformation zone, or the crumple zone that we were actually talking about, uh, okay, a couple of minutes ago. So these all are passive safety systems. Moving on to the dynamic vehicle testing, as you can see on your screen, I think it is clear. You can see there is a video that is playing. So it's a crash test without seat belt. Okay, so see if you are not wearing a seat belt while you are in the passenger part of the vehicle, while you are sitting behind or maybe sitting to the right or the left side of the vehicle. Okay, you must wear your seat belts. Other, if you are not wearing them, you are going to end up something like what this mannequin is actually experiencing, right? So these sort of tests are done in the homologation process to see what is the impact on the passenger and driver. We can see here there is on the left we can see a crumple zone crash test where we are actually finding out that when head-on collision is there, so how much shock wave is distorted or distributed so that the passenger and the driver are safe. As you can see in the left side of the animation, or sorry, the video, the front of the vehicle is completely shattered, and to some of you it will feel that it is not right, but actually it is right because it is shattered and divided into so many small pieces. So the shock wave has actually dispersed and distributed into different parts, and the impact of that shock wave is reduced, and the probably the passenger and the driver inside are safe. Okay. And then we have another test here, which is electric vehicle motor testing. So this is how the electric vehicle motors are tested. So we are almost come to an end of the session only. Yeah. So as you can see, these are the careers as homologation engineer. Uh, there are top three aspects, which is first is testing engineer, where actually you can do all these tests. Okay, you can design new tests, you can do all the tests and become a testing engineer. Then we have a homologation engineer, where we are actually validating all these tests, certifying the vehicle, and completing them, making them compliance with all the norms, emissions, and safety, and everything. Right. And then we have quality control engineer, which actually uh, keeps the check on all the quality of the components of the systems, subsystems, production, and everything. So this is the complete homologation session, and this is how you can get into homologation engineer as well. And yeah, that's it. So I am open to questions. So if you have any questions, please let me know. I'll try to answer your queries. If you all have any questions, please let me know.
If you have any doubt, please ask. You can also leave in chat box. We cannot share PPT. We can share a recording of this whole live lecture. You can watch that.
So for the educational requirement for homologation engineer is not as like there is no such course of it, but see what is that you can definitely get to know about the organizations that are there, which are actually testing the doing the homologation part of the vehicles, and you can get there, and they will only train you. So if you are able to get into ARAI or maybe NATRAX or maybe ICAT, they will only train you to become an homologation engineer. Okay, what about Moose test? Moose test is there to check the stability and the steering of the vehicle, steering aspect of the vehicle. And that also comes under homologation part only. Anybody else who want to ask anything? I'm asking for the last time, and then we'll end the session here. If anybody has any question, please ask. Okay, everyone. So I'll see you all next time. Thank you for being patient, and have a good day.
Thanks, sir, for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company, ISA India product and services that we offer in EV technology with small video. So kindly have a look on video.
As we are living in the fast changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and revolutionizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Jalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, E-Bike Design Challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Day Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youth for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, and which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions, and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing, and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQ courses aligned with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero MotoCorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Pelgotias University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop a workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this course, kindly send us inquiry to a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you.